Hey everybody, I'm Brian. Welcome to my Build a Place channel. In this video, we're going to be making a 3D printed bulldozer die for my compact bender. To 3D print this die, you first need to create a model. So I want to give you a quick overview on the computer on how I created this model. The software that I use to create this bulldozer die is Libre Atom 3D. It's a nice 3D package. I've used it quite often for projects around the house, kind of hobbyist things, and it does a great job. We're on the home page right now, and from there we can open up an existing design, or we can create a part, or create an assembly, or we can create a drawing of a part. So since down here at the bottom you have your recent files. So the file that we're going to be working on is this bulldozer die, 1.5 inch. So we're going to open that. Now the nice thing about a Libre that I like is that it's $199, and that provides you a perpetual license, so you can use that forever. You don't have to pay any other licensing fees. And they have an option that you can get a yearly maintenance for $50, and that covers, you know, the regular custom maintenance and updates. So here's the part that modeled. I'm going to turn it around. You can see my little bulldozer picture that I pasted on there. If you look across this area, this is where you're going to be doing most of your work. You can have an activate switch, activate 2D sketch, and then you can do different kinds of extrudes where you're adding material, and that's the one I use a lot. And then you can have the extrudes where you take away material. The other revolve, sweep, loft, and helix, whatever, those I don't use hardly ever. I do use the fillet and chamfer, and once in a blue moon I may use a shell command. But those are the basic tools that I use. So to get started on this, you start a sketch. So I've already drawn everything here. So I'm going to go down to the first sketch that I created, and I'm going to edit that. And you'll notice this menu up here will change once the sketch gets started. So, and it's getting ready to change. It should have changed. Oh, there it goes. And that is where you can draw your lines, rectangles, circles, arcs to create this outline of what you want it to be. And then to get everything right, you drive those lines with dimensions. So these dimensions drive that part. And then when you're finished drawing what you want to your outline, then you deactivate the sketch, and then you would go to the extrude, which was this command here. And I'm just going to edit that. I'm just going to go to edit, so you'll see what the menu. This is what the menu would look like. So to get that extrusion, I gave it to a depth of 2.3 inches. So you see here that image is going to, from that sketch down in the blue, light blue here, is going to go out 2.3 inches and make a solid block. And then you'll continue on. I can move this little bone down, and you'll see, I'll move down. Let me bring it up one. No, okay, then you'll see that I extruded out the hole, and that was the same basic thing, except I used this command here to extrude the hole. And then you go down further, one step further. This is where I added what I call the foot, and then you just keep on going down, and where I cut the notch out of the foot is there. There's tutorials that cover all this, you know. So if you're interested in this product, they offer a free trial. You can contact them. I'll put the link to their website, and you could get this package and learn. I mean, you just want to learn 3D modeling for $199. You can't go wrong learning how to do 3D modeling. And if you make projects in your wood shop, metal shop, whatever, you can draw everything up and make sure everything fits. And the nice thing is, now that I have this complete, I can go in and open, which I already created, a drawing of this. So it creates a 2D drawings from, you can show top view, front view, back view, side view. You'll see that I have like an isometric view of the part. Needs an update. It wants me to update everything. But here's isometric type view. This is the side with the little bulldozer image on it, and this is kind of the back view, side view, and then the top view. And then you can put your dimensions on that and verify that everything is right. So if you dimension this, if you modeled this wrong, you put this here, you wanted it to be a radius of 3/4 of an inch, well, you know that you made a mistake. So you can go back to the model itself and drive that dimension to get that right. So that's basically the drawings. I'm not going to go into any more detail. Like I said, there's plenty of tutorials for this software. So we're going to go back. We're going to close this out, and we may change, but I'm not going to save any changes. So from here, I want to be able to send this to a 3D printer. So my way, the only way I've created 3D printed parts, is I export the model as a step file. So you just go into here. It's going to pick a step file already. I already have that, so I'll just click it again. It's probably going to tell me I already have it here. So I just recreate that file, and it says it's exported in inches. That's important to remember, that it's in inches. When you import it into your 3D printing company, or I'm going to use a 3D printing service, you have to tell them what units you're using. So we're using inches. So this is ready to I'm going to send out to have quotes. To get my part 3D printed, I use Craftcloud3D.com to get an instant quote. So to get your quote, you just go here and pick Get Instant Quote. You upload your 3D model. So it's this bulldozer 1.5 inch die. So I just select that, say Open. Here's where you have to make sure that you select inches, because you can get millimeters, centimeters. So I go to inches, confirm that I want inches. It's going to upload that bulldozer die and show it down here with an image. And then you go to See Materials and Prices, and this is going to start populating the different materials that they can offer, and then it'll calculate prices over the side, and you can pick from a lot of different vendors, but they'll recommend a vendor usually for you. So let's let this thing finish populating. Okay, everything is up to date now. So as you see here, you can look for your material that you want, and then it gives you a price over here to the side plus the shipping cost. So you can scroll down here and look at all the different types of material we can get this part printed in and what the cost would be. So stainless steel would be $433. So I'm going to scroll on down there kind of slowly, but you can get an idea of what your part is going to cost from any kind of material that they have access to. So I'm going to pick this PLA Plus. So I just go $14.20. So I'm going to select that material, and then I'm going to put a 95% infill on that part. I want something kind of strong, in my opinion, so I'm going to pick that, and then I go to select the finished. I want it to be green, so it's going to cost $3 extra to get it finished in green. And here is where you can pick how you want this. So you go for the best price, their recommended price, and if you want something quick delivered, that's the price for something real quick. So I'm going to go with their recommended one at 44.82 and select that. And it's in the cart. So I'll just, from here, I'll need to sign into my account and do the purchase. Hey, die came in today. So let's take a look at this thing, see how it looks from the 3D printer company. It's packed up pretty good. See how this thing looks. That looks cool. Thing looks pretty stout and tough. Even got my little bulldozer icon or little bulldozer picture on it. So let's go over and try this thing out, see how well it bends. Okay, get ready to put this together. So we'll put the handle here, put our pin through the back of the bulldozer die. Made some changes, slight changes, so I'm not sure if everything is going to line up exactly right. I may have to do some modifying. I think I do have to modify right there. I didn't. Yeah, that's going to need to be that. All right, see where I got to modify this here. Made some updates. I cut this back further so that it won't hit the handle. I'm not sure if you see that. Oh, probably can't really see that. But it was, this part of the handle was hitting that edge there. So we'll continue putting this thing together. Let's get my pin that goes to here. Set that pin. Then I think it goes right there. So put a long pin right here. Get it to lock in. And then our custom 90-degree V formed into this pin with the index on it goes there. For the first test, I have a piece of 1/8" aluminum, and it's 1.5 inches wide. So I just set this in the die. Oh, we do have a little bit of problem. It's not going to do. Well, it'll do it, but I'm going to have to make additional adjustments. This face is too far out. Force it in there. When I did this model, I had the distance between here and this face is too long. So for this one, of doing an 1/8 inch, it's going to be pushing as hard as you can. So let's see everything out of the way. Okay, see how nice. It's a decent bend. I think we're below 90 degrees on that. I don't have my square. I'm pretty sure we're just below 90 degrees. Let's see if we can pull it again. Make it. I think it's just a little bit over 90 now. I'm not sure how well you're going to be able to see this, but it looks like it may, well, it's hard to tell, but it looks it's either 90 or just a little bit over 90. But it bent that with no problems. So I'm happy with it so far, what I'm getting. Let's see if we can make another bend back to back. Just my things need to be fixed, my dimensions on my model, but fix those dimensions on the model, and I think I want to have myself a nice bender down to horseshoe. I'm pretty sure this is 50-52 aluminum because I'm not getting as much cracking. I'm getting real light cracking on this edge. If it's 60-62, it's harder. It's going to usually crack on you, but that bent pretty nice. I'm kind of impressed. I have a piece of 1.5 inch, 1/8" mild steel flat stock. So I'm going to try, see how well that bends in there. And I could modify this die pretty easy. Just take it on the, probably just take it on the milling machine and mill that off a little bit. So let's see how well this one works. I guess did not give me a true 90 for sure. Let's see. Put it again. It's just shy of a 90. I don't know if you can see that, but it's just shy of getting a 90-degree bend. A degree off or something like that, maybe. But let's hit it one more time. Third time's a charm. Nope, still the same. It's just under 90. So it's not giving me a true 90. It's getting me close, but it's not exact 90. But I'm happy so far with what I'm getting. As for the male pin, what I did is I bought a piece of 5/8 inch rod and I cut it to 3 3/8 inches long. So what I'm going to do is I'm going to machine a 2 flats in this piece of metal so that when this die comes in at 90 degrees, it'll push right in nice and tight, give you a tight bend. You could take the existing pins that come with the tool, you could take them and use them as a die, and you'd have your radius would be 5/16 inch radius. So you could do that, but I wanted to make some dies for real sharp bends, inside bends for doing maybe like light sheet metal work. Whereas if you're doing something that's maybe that 1/8 inch bar that we bended earlier, this pin would work fine for doing that. So let's get started with this. To do this, I have a piece of 1/2 inch stock that I'm going to lay this pin right beside, and I'm just going to put a tack weld on this back edge. And then I'll mark where I want the flats to be. And then the grinder, I'm going to come in with a grinder and I'm going to use this piece of 1/2 inch stock as a gauge onto how deep to cut that flat. And then once that flat is done, I'll rotate this 90 degrees, or I'll break the weld, rotate it 90 degrees, mark it again to where I want the flat to be, and grind that area down to a 1/2 inch high. Now that the pin is complete, now I got to make a disc that's going to go on the top of here, weld on the top, and it's going to have a 3/8 inch rod that's going to index this these flats so we can make that 90 degree bend. So we're going to start laying it out. I'm going to use got a piece of 3/16 inch mild steel. That's going to be plenty thick enough to do what this needs to be. You could probably make it even, well, you make it a lot thinner than that because it's not going to really be supporting anything. It'll just be keeping this pin or die straight to the straight into the V on the bulldozer die. I already described a line 1 inch, just a little over an inch up from this bottom. Now I'm going to come about 1 inch away from this hole there, about, doesn't have to be exact, but I'll put a line there, and then I'm going to put a center punch mark on that intersection. And from there we'll see where it is. Now from here we're going to come over. This will be the hole for the pin. We need to come 0.668 inches. So I'm just going to use the pair of calibers and set them on 0.668. Come from that mark there. Probably lay it flat. Probably be easier to lay it flat. And they describe a line right there. It doesn't need to be that much of a line. Just so I can see it, to put a center punch mark. So I'm going to put a center punch mark there. That's going to be the 3/8 inch indexing pinhole. This will be the center for the actual pin. Now we got this marked out. We'll go over to the drill press. We're going to drill this 3/8 hole out first, then we'll drill out a 5/8 hole. Then we're going to take the hole saw and make a 2-inch disc after that. Okay, the first hole we're going to do is the one that's going to be for the 3/8 inch hole. So we'll just line this up, and we're just going to drill the pilot hole first, and then we'll drill the real hole. Get this pilot in. I'm just going to put one clamp on. That will keep it nice and still so it doesn't go anywhere. Let's check our. It's looking good. A little bit of cutting fluid on it. Okay, now we have to get everything moved around so we can do the 5/8 inch hole where the pin is going to, regular pin is going to go in. So we'll drill a pilot for that too. So let me get this out. Drill back in to make a pilot. I need both these pilots at one time, but it's just as easy to do it this way. Once you get it lined up and tacked down or tied down, I'm using right height clamps. They work really nice for doing this work. Get everything set where you want it. Once you have where you want, there's no stacking everything up. You just roll it right over where you want it. And clamp it down. This table just has slots, not T-slots, so you have to rotate the pin right. I may have to move this. This clamp may have to be moved a little bit. When I put the hole, no, it won't. It should be fine. When I put the hole saw in, I may have to move this clamp. This clamp should be in a good place, so it'll be out of the way of the hole saw as it's spinning. Still good. Still good. Okay, start up. For the 5/8 inch hole, I'm just going to be using a step drill. The steps are a little bit shorter than that 3/16 inch, but I think I can either take and follow it out or hold it in the vise and drill it from the other direction, whatever I can't get through. So it's 5/8 is this one right there. So it's going to be 3 down from the top. So put a little bit of fluid on there. got to 5/8 now. Yep, we're at 5/8. We got a little piece down at the bottom. We have to file out that little piece. I don't know if you can see it on the camera, but there's a little piece like a burr down at the bottom. We'll have to file out. Next step is to drill out the disc. So that's going to be a 2 1/8 inch hole saw. So that will give me approximately a 2-inch disc. This thing on the drill press, I don't like drilling the drill press with hole saws. I'd rather do on the milling machine. This one here is, this claim's good, but the other one's going to move. Oh, it's going to hit. So it's going to chatter. I know it's going to chatter some. That's not good when it starts chattering. Not good for your hole saw. We're going to do our best to keep it from chattering as little as possible. We'll get some fluid on it and I decided to stop the camera. There was so much chattering and everything, making a lot of noise, so I just stopped the camera. There's your finished disc. You can see I need a little, I don't know if you can see that on the camera, but a little burr there, and there's a burr coming around there. But now I have a disc that has an alignment hole for that pin. So we'll go over the other bench. We'll clean this up a little bit and get ready to put the pins together and tack weld it up. This is where I'm taking the alignment pin and this center pin, or the bending pin. It needs to align with the bulldozer die. You notice the bulldozer die is at a slight angle. So the V of the pin needs to angle into that slot in the bulldozer die itself. So that's what I'm doing there, getting that straight, and then we'll tack weld that and then finalize it with a rear weld. I got all the tacks done on both the alignment pin and the main center pin. And now I get the bulldozer dies off, so I'm just going to take and weld that piece all up. Okay, now we got this pin all done, so let's put this bulldozer die back together again, and we're going to try it out, see how well it does with that pin, with a piece of, I have a piece of 1/8 inch mild steel, 1.5 inches wide that I'm going to use. So we'll see how well that does with the bender. Get this in the pin. It's in the pin. These pins just seem real sloppy. So we'll put the pin with the indexer on it. We gotta get this. Oh, gotta go back one more hole. It's this. We come back 2 holes from the back, and get this to line up. That looks good. We already made one. There's already one bend on here that we made. I'm just going to put another one in. Remember, this is going to be tight going in because I need to make some adjustments. So we'll go right there. We'll see how well it does. Make a 90. I have to pull the pin out to get this out. There's. Oh, I didn't leave it. I did not leave the square out, but it looks like it's just a little bit less than 90. Just looking at it from there, but it's pretty close for bending a 1/8 inch by 1.5 inch piece of steel. So that's probably not what I'm going to be using this thing for. It's going to be more lighter metal than this, but I'm pretty impressed with the 3D printed part. This concludes a video of the 3D printed bulldozer die. I hope that you enjoyed watching this video. If you did like it, give me a thumbs up. If you like my channel, what you've been seeing lately, subscribe to my channel. And if you have any comments on this bulldozer die, leave comments in and I'll try to reply back. The software that I use, Alibri Atom 3D, is really an excellent software for, like I said earlier, to learn 3D modeling. And actually, if you have a hobby where you're making things, you can make all the parts and make sure everything works and fits together. And if I could have modeled this bender and I would have seen that I needed to modify this piece right here. So, and Craftcloud 3D is a service to get quotes and do purchasing. I've been using them, I think, 2 years now and haven't had any complaints. It's excellent for getting instant quotes and actually putting the items in the cart, and you can purchase everything right through their service bureau. And it just works good. And then the part comes in. I don't have to worry about having a 3D printer and dealing with all that. And I think this part was something around $30 with tax and shipping. So it's a lot better than my predecessor that I did probably over a year ago, maybe going on almost 2 years ago. I made the metal one and welded it. This is going to work so much better. And the nice thing is, now that I have this modeled, I did have another model, the die opening. I can change the width of the die opening. I can change if I want a radius inside there. If I want to make it more of an acute angle, I can make an acute angle in that. And the possibilities are endless with 3D printing. I'm finding out more and more. So the other thing is, I'm not sure the logistics of doing this, but I was considering uploading this model and the drawings to my Dropbox account, where it could be downloaded from there. So give me comments on that. I'm not sure how I'm going to do that exactly, but I'm considering it right now. So if I get enough comments, I'll consider it even more too, so that all you have to do is just take this step file and you can upload it to wherever you want to upload it to, or if you have your own 3D printer, you can just print it on your printer. So that's a thought right now. So send me comments on that too, and on to my next project.